In this section, we continue our practice how to compute derivative. The derivative of the function sine is just cosine. And now let's have a look at some small complications. If we multiply the function by a constant, then the derivative will be just multiplied by the same constant. So 2 sine of x derivative is 2 times cosine of x. What if we multiply not the function result, but the argument? This is now a composed function. So the derivative is the derivative of the outer function. Derivative of sine is cosine. But now, not just x. We must copy the whole argument. If it was 3x, then 3x. And then we multiply by the derivative of the inner function. And the inner function, 3x, has derivative equal to 3. So we multiply by 3. Not to confuse this, it would be better to close cosine of 3x into bracket, or to write the multiplicative constant in front of the expression 3 times cosine of 3x. So this multiplicative constant in the argument appears twice in the result. First, as the multiplicative constant at the argument in a similar position that it was before, and also as one more multiplicative constant in front of the function. What if we don't multiply? What if we add a constant? Well, adding a constant changes nothing. So derivative of 2 is 0 plus derivative of cosine, sine is cosine. And we don't have to write 0 plus something. And similarly, here we multiply the argument by some constant. What if we add some constant in the argument? Then derivative of sine is cosine. And again, we must copy the entire argument as it was here. 3 plus x. And yes, indeed, this is also a composed function. So we must multiply by the derivative of the inner function. But the derivative of the inner function, 3 plus x, is just 1. So we don't have to write times 1. What about if we combine these two complications, multiplication, the function, and multiplying the argument? Then 2 times cosine of 3x times the derivative of the inner function. And 2 times 3 is 6, and it's a good idea to write it on the left. So we have 6 cosine of 3x. What about this complication? We take x, we compute sine, and then we compute the second power of the sine. So remember that x squared alone, derivative is 2x. So something squared is 2 times something times the derivative of the inner function. This time the inner function is sine, so we must multiply by derivative of sine, which is cosine. Well, if you like, this can be simplified a little. This can be written as sine of 2x. Now, what about if we compose the same functions, sine and square, but this time in the reverse order? Here we first computed sine and then square, the second power. This time we first compute the second power of x and only then the function sine. So derivative of sine is cosine. We copy the argument times the derivative of the inner function. Derivative of x squared is 2x, so we must multiply by 2x. And again, to avoid confusion, it's a good idea to write it as 2x times cosine of x squared. What if we multiply, not compose, what if we multiply these two functions? Then this is derivative of the first expression, x squared is 2x times sine plus x squared times derivative of sine, which is cosine. We did not consider the question about the existence. There is no condition for none of these functions, so all this was for any real x. Now it will be different. First, there is no x. This space is not multiplication. This is a composed function. The first, the inner function is logarithm, and the outer, the second function is sine. So the derivative is the derivative of the outer function, derivative of sine is cosine, we copy the argument, times the derivative of the inner function, which means times 1 over x. Well, and what about the condition? For logarithm to exist, x must be positive. Sine can be computed for any argument, no problem. Similar for cosine. Yeah, logarithm requires the condition x is positive, and this fraction requires x is different from 0. When we write x is positive, this includes already the condition for x being different from 0.